Okay, so we are going to focus on the math behind a strong acid, strong base titration. So I might do this as a demo maybe on the Monday because, again, some of you didn't even get to do this in grade 11, where you use something called a burette and you they're $92 because their calibrations are so good. So you can make a solution that's perfectly neutral. So it doesn't matter if you start with an acid in the flask or in the burette, but whatever's in the flask would be opposite. So base acid or acid base, doesn't matter. And you would add, and one of them you would know the concentration and one of them you wouldn't, and then you would add the other one until you saw a color change. So let's pretend like we had, maybe if we had an acid in here, the most common indicator we use at St. John's is bromothymol blue. So again, in your grade 10 class, you would have used that for sure. So when you had an acid, the acid would be yellow. And then once you start to add base, so you can kind of see here there's like a little dot. Once you started to add base, so base to an acid, you get neutralization, right? Which would mean that the indicator would change color. So what happens is you start to get what you would start to see, so you can kind of see there's a darker dot here, is trying to show you that it would start to turn blue. And then you would try your very best to get as close to neutralization as possible. So what color do you think you would see? Yes. Which can be difficult to do. Students often compete with each other. They're like, no, mine's greener than yours. Yours sucks, whatever. They're mean to each other, okay? But so when you wanted to get neutralization, then you would use the indicator to see or visually determine the equivalence point. You don't have to use bromothymol blue, but that's often what we use at St. John's, okay? So we are equivalence point, is when moles of acid or base, whatever, are equal to each other. So moles is C times V. So qualitatively, you use a color change to figure it out. Quantitatively, you use CAVA equals CBVB. What do you think A stands for? Good. And B stands for base? So when are the moles of acid equal to the moles of base? So we did CAVA equals CBVB last year. But that was it. That was as far as we took our quantitative analysis of this. This year we're going to look at, yes, what volume would get us to equivalence point, but we're also going to calculate pH. What's the initial pH and what's the pH after you start adding some of the other substance? So what will happen is you can build something called a titration curve. Which is what's next on the next page, or on your page. So now a titration curve shows the initial pH at the bottom here. So now this pH is very low. So this is acidic. And once you start to add base. So you're adding volume of base added. Then the pH is going to increase. So it increases slightly, 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 slightly. And then you would see this very sharp peak. So what happens is with a burette, you could literally add one more drop and your color would change. So it can be a little bit frustrating. Students get mad. I was so good. I let the drops in so slowly. All of a sudden it changed. Because it really does happen like this. One more drop can change the pH drastically. And then after the equivalence point, now you've got excess base. So then the pH becomes higher. Okay? So we are going to focus on strong acid and strong base titrations. So at equivalence point, this was on the, I think it was the first slide even of that note. At equivalence point, you get a perfectly neutral solution. So pH is 7. And if you were given a graph, a curve, that you're not going to have to do this, but let's say you had to go the other way and you were given a curve, then this equivalence point, like if you measured this line, this is exactly halfway. Of peak, in the peak, of the peak. You should get a pH of 7. We're just going to do the math part of it, not the graph part. And it says that here, midpoint of sharp pH increases equivalence point. So if you were given just the curve, you could figure it out. So you could, I can't remember if I left the question on the exam review. It talks about the curves and is it a strong acid or strong base? So you would be looking for the pH of 7 in the sharp increase. So if it's not a strong substance, like say it was a weak acid, then the graph would be shifted toward the basic side, and vice versa. If it was a weak base, then the graph would be the other way and sort of be shifted down at equivalence point. Okay, so we're going to do an example that's exactly like the question on the exam. Okay, so star this, please. And if you look next, the next page in the booklet is a worksheet, and it's basically doing these calculations we're going to do once we start adding base over and over and over and over again. So tons of practice so that you're like, I got this, good. None of the math we're going to do today is new, except actually calculating pH. Maybe you've never used a log scale before. Although last year we talked about it where it was like if you do a jump from pH of 1 to 2, then we said it was 10, right? You had to go 10, 100, 1000. It wasn't a jump of 1. That has to do with the log base. Okay, so we are going to calculate the volume of base required to reach equivalence point. So we are starting with hydrochloric acid. Hydrochloric acid is an acid. Okay, so this is milliliters is volume. Big M is moles per liter, so concentration. We are asked to find the volume of the base. So this is the concentration of the base. I chose to use different numbers here so you could see where they were coming from. The concentration can be the same, but it doesn't have to be, okay? So we're going to do we're going to find where the moles of acid and base are equal at what volume. So again, don't tell my grade 11 students, but because it's got volume on both sides of the equal sign, you can actually leave it as milliliters. You can rearrange before you plug the numbers in or plug the numbers in first. Doesn't matter. It's most important that you put the volume of acid with the concentration of acid, and then put the correct concentration of base with the VB, so you solve for the right thing. So you're dividing. Decide how many steps you want to show. Point 0.3 times 20 divided by 0.2 is 30. It does not have to be a nice perfect number like this, but it makes things a little easier, so it probably will be. So now you know 30, that would be where the moles of acid and base are equal. So we're going to do 2 more calculations. We're going to do 0 milliliters and 10. So 10 is less than 30, so our pH is still going to be acidic. We have not reached the point where it's going to be 7, okay? When we do the initial pH without the base added yet, then we can just look at what the acid is. It's still by itself. It should be very low. And then once you start to add base to it, our number should get higher, okay? So you can kind of check the logic of your answer and make sure you're on the right track. So now we're going to calculate the pH of the solution after the addition of the following amounts of base. If you want to add in here the acid, you could do this the opposite way, where you start with the base and then add acid to it. It's fine. It would be the same thing, except you would calculate POH and then have to change it into pH. So whenever you have a base, there's always that extra step, okay? And it's not hard. You just do 14 minus POH, but you have to remember that. You're never usually asked for a POH answer as your final answer because we don't have a POH scale. So we don't have any base added, so this is just the initial pH. So we can go straight into the pH formula. Really, when you do this, this is like, you'll see on Monday that the questions, you have to do ice tables and all this kind of stuff. When you have a strong acid, then it's easy. You could even just go right into the pH formula, but what I'll do is I'll write it out again. Like, you can quickly write a dissociation. Yes, please. Thank you. Okay, so the concentration of acid is 0.3. That's over here. Okay. And then, so it's 1 to 1. So this is 0.3. So once we start adding base, our pH should increase from 0.52. And again, the worksheet has many, many, many increments of increase. We're just going to do, we go from 0 to 10, okay? So what I'm going to do is on the left, I'm going to write in general what I'm doing, and then on the right-hand side, I'll do the math specific to this example. So if you want to put your note like that, so later on when you look at it, you know what I did, that's fine. If you'd rather just write the math, if you're like, no, I got this, you can decide. It's up to you, okay? So the problem with this, once we start adding base, neutralization occurring, like proton transfer, but you're also going to add volume. So the acid solution starts at 20 milliliters, and then whatever the question says, so just read the question carefully. So we're going to add, it says to add 10. So if we have 20 and we add 10, what's the new volume? 30, right? So yes, it's impacted by the proton transfer, but it's also impacted because you're adding more water, which is going to make it less concentrated as well. So we have to take that all into consideration, okay? So we are adding 10 milliliters of base. So we need to use that 30 eventually. To figure out what our new concentration is. So, do we have the same amount of acid and base in terms of volume? No. So what we need to do is change the concentration using whatever volume we're given into moles, and then we can start comparing things. So you have to figure out how much moles you have, how many moles are added. So in this case, we start with acid and add base to it, and then we can figure out how much is left over, or sometimes that's called unreacted, because the stuff that's left over, unreacted, is going to influence the pH. Okay, so the initial moles of the substance in the flask. It could be an acid, it could be a base. In our case, it's an acid. So when you do the calculation, you can write N acid so that you know. This time, there is no volume on the other side to counteract the conversion, so you have to change volume into liters. If you need a little reminder for yourself, milliliters divided by 1,000 is liters. So the concentration of base is not the same, and neither is the amount, right? We're going to use 10 milliliters of base. Its concentration is 0.2. Okay, so the moles of acid and the moles of base are not equal yet. If you want to even, you can write like AABB to emphasize it to yourself to make sure you're using the CB. You could even label it up here too. So this year, it's just 1 to 1, okay? 1 mole of acid to 1 mole of base. So if you start with 0.006 and you add base to it, all you have to do is subtract. Let's say you subtract the wrong way and you do 0.002 minus 0.006, what will happen? Right. And can you have a negative mole? No. So then you're like, oh, darn it. I just have to flip it around. That's it. Okay. So I'm going to write N unreacted equals N initial minus N added, which is fine. That's what we're doing. But remember, you can think about your answer logically. I should not get a negative mole. I subtracted the wrong way. Okay. So this year, we want to always get down to pH. So in order to do pH, it has to be concentration. So we have moles, but we need to find concentration first. So if you forget the concentration formula, it is in that equation box on the exam, okay? I don't want to squish, so I'm going to put more than one equation on the line. Sorry. So we've had neutralization, take away some of our moles, But remember, we also have a new total volume that's going to affect how much water, how concentrated it is as well. Okay, so we already wrote down what that was. You just have to change it into liters. Okay, so you get 0.9. Is that higher than 0.52? Yes, it sure is. So we're working on getting to pH of 7, but we calculated that to be at 30 milliliters and we're only at 10. So you would have a long way to go. Okay, so the page after that in the book, that is the worksheet. Again, it's really doing this sort of over and over and over again. So it's up to you if you'd rather spend time studying for the part 1 of the exam and do this later. That's fine. It's up to you. I do want you to hand this in. So the mathematical relationships 1 and the Le Chatelier's principal lab, please. So if you're not done those, you can work on those as well.